Okay, so for example, sure.
we see label it as an example, right? But like because this will label it as like a value. I think we all just kind of match the wording with like the process and then not having the words.
Okay. Well, so if I ask you ever to do this. Here's the problem. You might say evaluate or figure out the integrals or whatever. So how would you do this? How would we do something? So, I don't know. That's one way. So, for example, what if there you see is on the antiderivative? This one? Yeah, I agree. So let's do two parts. So this is just a simple matter of using the fundamental theorem of calculus to get some number. Represent in this case, the area of the curve. So what do you have to do this problem? Fundamental theorem of calculus says if you can find it, take an antiderivative of this, plug in the top, minus plug in the bottom. That's it. So can somebody tell me an antiderivative for 2x plus 5? Small bits, 2x first. You're 1 power too high. It's too high. Should be just x squared. X squared over 2 times 2. And you know what? Here's the great thing about this. You can check, right? Root of this 2x, ding, ding, ding. How about 5? Very good. Now you got to plug your inputs right, and you're good to go. So this should be 16 plus 20 minus 0 plus 0, 36. There you go. Okay, that's one amount. See another one that we can get an antiderivative for. I agree with you again. Let's probably do that. So let's do three the same way. This one requires a little bit more cleverness. And somebody give me an antiderivative. So we might have to play with this. Somebody give me an antiderivative cosine 2x. Okay, so now you're on. If I had said cosine x, instead cosine 2x, just snap that out right away, right? Sine x, right? The problem is that stupid 2, right? I'm attempting to say cosine 2x, or I'm tempted to say sine 2x. Right? Because in the first step of the chain rule, it's works, right? The root of sine of blob is cosine of blob, right? But is this right? What's the problem with this? Derivative of this is not cosine 2x, it is what is it? Is it Oh, that's gonna complicate things closer. We are so close here. What is the actual derivative of this orange thing? Right, so the derivative of this is cosine 2x times 2. Right, that's what's killing it. So it's not a match. Can you fix that? It's only times 2, so how about that? What's the derivative of this? Cosine 2x times 2 times a half. And it smooths it out. You can only do this with constants out there. If that had been sine of x squared, cosine of x squared would be a problem. Okay, you follow the pattern here. What about that? I'm tempted to say e to the 3x, aren't you? And quite work. And again, the good thing is you can eyeball this, and if you take the derivative and get back where you started, you win. What's the derivative of 1/3 e to the 3x? 1/3 e to the 3x times 3. And that takes care of that 1/3. Well, let's go backwards. Let's take the derivative. This is 1/2 cosine 2x times 2 is the chain rule. And that 2 is just what the doctor ordered, cancel 1/2. What's the derivative of this? That 3 is just. So this requires a little bit more cleverness, but we can still get an antiderivative. Do I agree with it? And so now it's just the tedious matter of plugging it in, which this is not a serious step, actually, in my opinion. So this is 1/2 sine 8 plus 1/3 e to the 12 minus 1/2 sine minus 2 plus 1/3 e minus 3. Whatever that crazy number is the answer. Any questions? We've done them all except for number 1. That's it. You're thinking of. Unfortunately, it's easy. Yeah. Well, you could, but you're not going to be able to get an antiderivative this yet. Right? There's a substitution that you need to do, and you can still do this interval. Right? So what to do if you honest to goodness for true can't find an antiderivative, play around with it, you can't figure it out. Everybody think that you can get stuff like this by playing around with it? Maybe. This one, too hard. So just play around. So how do we do it? Well, here's the thing. For test problems, I'll give you things, and then I'll give you a fourth way to do it that's real world, right? For a test, fundamental theorem of calculus, can you find an antiderivative? Oh dear, I can't do it. Number 2, is it an odd function or an even function? So you're already on that. There's some kind of something we can take advantage of. Number 3, can I draw a picture of what the function looks like in each geometry? Real world number 4 is break that up into boxes and don't even find the limit, just approximate it. Right? But here we can get exactly. So here, this is telling me that's the thing that I'm integrating, right? Let me massage this and see if I can figure out what it looks like. So if I play around with this, I get x squared plus y squared equals Somebody describe this to me. Circle. Its radius is 2. And actually, this thing right here is the upper half. Because the equation it's speaking to me, it says, hey, look, Jim, my y coordinate is positive. Right? And so it's just the upper half of the circle. Right? The whole circle is not even functional. Right? Those vertical line there. This is telling me, hey, look, my y coordinate, this is all the crap on the circle. It comes from this equation where the y coordinate is greater than or equal to 0. Because it's the square root. Well, so notice I've also got convenient limits. Circle is radius 2, so that's minus 2, and that's plus 2. What's the answer? Where do I get that? What's the area of a circle of radius 2? Radius squared. But this isn't the whole circle. It's the upper half.
I thought you got there with the unit circle.
No. This is actually bigger than a unit circle. It's actually got radius 2. That makes sense. So that's what it is, basically. When I do an interval, there's numbers on it. You're going to use the fundamental theorem of calculus, doing a definite interval. Fundamental theorem of calculus, is it an odd function? Is there some kind of symmetry I can take care of? Or am I going to use some kind of geometric thing? Is it lines, or is it some kind of curve like a circle where I know it here? Okay, let me get this here. Was it 2x minus x squared? Okay, so yeah, I didn't pull any punch because that was the part C. That's what you wrote down.
Actually, it's not the limits.
Yeah, let's do that one.
Okay.
Hang on to your thought about the limit. Do that one too. This is a circle as well. It's harder to see. Like this requires a little work. So what we have is we have y is square root of 2x minus x squared. Right. Now, what I'm going to do, I'm going to do just what I did in the first video. I hate that square root, so I'm going to get rid of that square root. Not squaring. Now, in the next move here, what I'm going to do is how many remember completely square in the day, right? Just all of them, right? Does anybody know what I can add this to make this perfect square? What can I put right here to make this x squared minus 2x? Y'all remember how you take the x term and cut it in half and square it? So what's that one here? And let's see, why is this going to work? What's this strip right here? Well, right, but can you factor this down? Yes, this is x minus 1 quantity squared. Right here. Now, remember, I'm not done with this because I added one. You don't need something out of nothing here. So if I add one here, I better do it over here. So what I get at the end of the day, y squared plus x minus 1 squared. 1. Now, here's a reminder here. This is a general equation of a circle of radius r, centered at point A, B. Right, notice when A and B are both 0, you get excluded twice. You all seen this like an hour or two in your travels, some point or another. So let's try to identify this here. This is a circle of radius what? And steal off that equation, which radius is big. That is your r squared, so your r should be 1. And it should be centered at 1, 0. Export. So what does it take to what value for x to make that 0, 1, and y 0? So this circle here looks like this. 1. So this problem right here is actually asking you this. So my function here, y, that's actually the upper half. Again, you got the square root of the positive. It's the upper half of the circle. So it looks like this. Zero, 0, 0, 1, 1. Successful area. Because this function is. By the way, there's some good gut checks. Math is really good to you. Learn to don't let the math you use. You use it. I'm not sure about that. What happens when you plug in 0 for x? You square root of 0. So 0, 0 is on here. What happens when I plug in 2 for x? 4 minus 4 is 0, and your y coordinate is 0. So that's kind of a good gut check. And the radius of this is 1. So what's the area of this? Radius squared, then half of that. So yeah, that was definitely a good metric right there. So you had other concerns though. So what problem do you all look at? Square root is 9 by 16. Okay. So yeah, these are a couple of problems from earlier. Let's see. Oh, wait a minute. 7 over. Okay, so let's do this one. What's the first thing to do with any limit? Exactly. Stick it in and just see what you get, right? Well, if I stick in X4 here, I can 0 on the bottom, right? What about the top? Actually, it's getting 0 as well, because it's integral from 4 to 4. See the next. So it goes nowhere. So this is 0 for 0. And if I remember right, that's a good time to try a little top one, especially since the top function looks like that. I mean, you're not going to factor it, you're not going to mess. So let's try what we call for. Ooh, I'll bet you do the bottom, just the bottom. Do the top one, we only require the fundamental theorem of calculus. So you take this thing into the interval, plug in x. What was the top one up here? Is it x squared or was it x? It's just x. X squared plus 9. Minus, plug in 4. 5 times the derivative, which is human, right? So it's plug in x times the derivative of x, which is 1. Plug in 4, derivative of 4 is 0. So this is actually x goes to 4, x squared plus 9 over 2x. I hope you. This is easy down here. Does everybody understand? Step I couldn't think through. Okay, so now I've got a new problem. What's the first thing to try? Plug it in. What do we get? 8 in the bottom. That's a great sign. 16 and 5 is 25 squared root of 25.
Yeah, I'm pretty sure I got like 1 of the years.
Right, but is this clear now? What happens? Like that was another. Yeah, what you got? Is everybody okay? Now, I didn't really require this. But let me ask you this. Again, let's analyze. I can't really plug in infinity. But let's kind of analyze what happens. As x goes to infinity, what's happening to my bottom? 3. Right, okay with that? What about the top? The top also goes to infinity. Well, and I didn't really demand that you do this, but let me point out that square root of t squared plus 9 is bigger than square root of t squared. It's bigger than t. If t is positive. Everybody agree with that? Now let's see what happens here. 4.44. Now look at the function y equals t. What's the area under this curve out here to x as x goes to infinity? Yeah, it's infinite. Everybody agree with that? So that's a justification. But really, what we get is infinity over infinity. Right? This means the local is kosher. Be given a world. Two x just like before. And just like before, I get the square root of x squared plus 9. And now guess where I find myself? In 1040. Because this is the calculator. Non. it makes it more complicated. What will happen here is this is x squared plus 9 to the 1/2 power, right? When I do this, get an x squared plus 9 to the minus 1/2 power, pushing this down here, pushing this up here, it'll just go kind of back and forth. It's nice. First things first, somebody just put their eyeballs on that and tell me what that number is. Should be able to do that. It's true that both the top and the bottom are going to, but holistically, the entire fraction is getting close to 1/2.
How do you divide by the x?
So here's. So let me do a quick review. This isn't going to hurt. So. Zero, that's right, how do you know that? Okay, everybody agreed that the x squared totally gets the letter x squared. Now you can do what we call rule on this, but the easier way to do this is this is easier to see from Patterson. I divide top and bottom by x squared. Right. As x goes to infinity, 0, top's 1. Those are getting close to 0. This is getting lower. So that's right. And if I'm going to minus infinity, what would that be? Oh, very good. It'd be positive infinity because very large negative values, that's negative and that's negative. Very good. So here's what happens when the top loses to the bottom. The bottom actually beats it. You go to 0, plus or minus. When the top beats the bottom, you go to plus infinity or minus infinity. What about this? Where it's 3x. Right. Now you can do both tall rule if you like. You get a nice answer. To get it completely clear, you have to do it 47 times. Right? I'd rather not. Actually, I guess, yeah. 47 times. 46 there. The easier way to do this, when you have a tie, it's the ratio of coefficients. So, easier way to do this is just divide by the dominant power. 1 over x to 30 plus 12 over x to 24 plus 4 over x to 7. 8 plus 1 over x plus 1 over x to 37 and 17 x to 47. And all this crap here goes to 0. You left with your 3x, right? What about this? Right, so here's what I'm thinking here. This looks about like x over 2x. For very large values of x squared plus 9, and then take the square root of it, that's not very different than x. So I'm thinking that's an x, that's a 2x. We be careful if it shows this is exactly true. The power, the biggest power on both the top and bottom is x to the 4th power. Right? So if I top and bottom, I 1 over x. Right? one over x is easy enough here, but I need to be able to slide this inside the square root. I'm gonna do this. So this is. That's up. That's going to use 2. And under the square root, we get 1 plus 9 x squared. And now it's clear what happens. But if this piece goes to 0, okay. Because it's math class, I gotta make sure that I'm leading down a bad path. But let me ask this. Well, I guess what this one is. Biggest power here is like square power. First coefficient is about like 2. So this is sort of like a 2x squared up here. The biggest power that I have here is 18/9. It's also good. We have a tie, which would be the ratio of leading coefficient. And the first coefficient here is very much like 7 to 1 power. Multiply top and bottom by 1 over x squared. Just to put radical here and 9 root here. And
Maybe like simplify it.
yeah, but I don't really see you simplifying that. That is just, that's a train. Let me get, here's my word of caution. I see where you got that. The square root 2 is, it's not 1, it's a little closer. It's actually negative. Okay, so let me tell you. So it's tempting to say the biggest power you see up here is 1, right? X is 1, and it should be square root of 1 over the coefficient of this is 1, right? Over 1. The problem is with negative p, there's no way it can be positive. No way, no way. The reason is that thing in the numerator, positive always. If you're going to negative infinity, that's negative. So this limit is negative. It's at most 0. So let's do this. Multiply top and bottom by 1 over x. Remember how we put this in square root? Apply it under there. Are these two the same?
Yeah.
No. Not for negative x. Because this thing on the right side is always positive. And if x is going to negative infinity, that's negative. This is like an absolute value. So what do I have to do? How do I make these equal? Well, this is negative. So here we go. Now they're equal. And so now what happens is, if you're super careful, that's 1. Now you get -1. So your answer was on track. You got the right magnitude wrong sign. Let me point out, you can't just throw everything to the wind about negative infinity, because this one this is 1x squared, 1x squared. See, now both the numerator and the denominator are positive. Squared comes out. Did you all see this kind of stuff in 1040? Okay, what else we got? Okay, what else we got? So, the one that he's talking about? No, it's more than that. So, remind me the integral was, the integral from -1 to x of t squared. Right, and x bigger than -1 maximizes. So what we want is right. So, and of course, that's another thing that you have to get used to when you tackle problems in engineering science, right? Because problems don't come in. Right. So let's think of it this way. Does this look like a familiar problem? The kind of problem you've had before? I take it, I give you a function, like when we did optimization. I said, okay, here's a function on the interval from -1 forever to infinity. Find me the maximum value. That's exactly what this problem is, right? Because this I can identify as a function. What is my function? Now, find how big this function can be on the interval from -1 to infinity. Don't let the fact that I'm writing this interval as a this way confuse you. I mean, easy in certain sense, because I made it a little bit more foolproof. I'll do it another way. Fine. What's the first thing? So when I give you maximum, say, okay, here's a function. There it is. I want this to be as big as possible on the interval. Then, what's the first tool that you need to pull out? What's the tool? You need the derivative, don't you, right? So that you can find one of these critical numbers and try to figure out where it's big and possible. So this is the main thrust. This is the new thrust in this problem here. What the heck's the derivative of that? And this is the fundamental theorem of calculus, and it's pretty easy because it's just x. Right, so plug in x times the derivative of x. Plug in -1, derivative -0, so there's no. There's your derivative already in factored form. How lucky are you? Right? Okay. When you did a maximum problem, the first thing you did is got a derivative. There it is. We've got it. What's the next thing that we did? We found the critical points that are in our playground, right? What is our playground? We've already got it. What are my critical numbers here? Agreed. Well, that's just a variable. So here's our playground. It goes on forever. And I've got a couple of critical numbers. I've got 0, and I've got 3. Now let's analyze the sign. Let's look at our derivative. What happens when you're in this range between 0 and -1? Say -0.5. That's going to be positive. That's going to be positive. So it's positive in here. What happens between 0 and 3? Something like 1. Positive, positive. What happens when you're beyond 3? Say something like 10. Positive, negative. Up. So it increases, and then decreases forever. So what happens here? That is correct. It's a local max. And it is an absolute max on the interval -1 to infinity. Because here's what happens. The function goes up and then down forever. So you're never hitting that apex again. You go up to it and then you go down after it forever. Right here. So not so bad, right? I mean, it's just the techniques that we've done before applied. The only thing that's different at all from what we did before is these fundamental theorem of calculus. Take that derivative. By the way, here's another way I could have written the problem and get the same answer. You can actually write down what f of x is in this particular example. Because f of x is the interval from -1 x 3t squared minus t cubed. Everybody see where I got that multiplying that. Now I can use fundamental theorem of calculus 2, just write down what this is. This is equal to what's your favorite antiderivative? 3t squared? Agreed. And how about t cubed? Good. You know, hold on. So our function explicitly is plug in x to this. When I plug in -1 here, I get -1 -4. -4. So I get x cubed -1/4 x4 plus 5. So I could have written a problem this way. Here's f of x. Find the maximum value of this function here on the interval from -1 to infinity. It's the same thing. Okay, so if you're, so let me do this. Let me do one. Find out those. Let's see. Okay, so here's a couple of problems. Tell me, I might just give you this function. I didn't know what it looks like. Maybe I'm curious what it looks like. If I'm curious what it looks like, what do I need? I need my derivatives to graph it. Right? So the first question that might come up is you might say, well, what's that prime of x? That might be my question. And I would use my more general version of Fundamental Theorem of Calculus, part 1. And this is plug in top function for t. Comes derivative log x, which is what? Minus plug in the bottom. What's that? Later. Yeah. So then I plug in the bottom function, sine x, times the derivatives. Right. And that's the answer to the first question. What's the derivatives? Now, I might say, rewrite this function in terms of something more familiar, using the fundamental theorem of calculus part 2. Well, for me to use this, I need to know an antiderivative. See here, I can do that. And we'll check ourselves. Okay, these are no different from numbers. Okay, so let's try this. So if I were to evaluate this and figure out another way to write that equation, what's your favorite antiderivative for sine theta? Antiderivative 2 theta. And we evaluate that from sine x log x. So everywhere I see a key, I'm going to put that in, and I get sine x plus sine x squared minus sine. Dang it, put your phone in first. My bad. Put the top one in first. I put sine log x plus natural log x quantity squared minus sine x plus sine x. Everybody agree with that? So just sort of keep myself with the signs, SIGN. We'll go ahead and do this. What this means is this function here, I write it this way to be fancy, it can also be written this way. This, same thing. Okay. Let's check the derivative here. Color. This is f of x. F prime of it. Okay, let's go through this. This is a good change of factors. How do we take the derivative of sine of log x? It's the first thing I come to. Cosine blob. Am I done? Got to multiply by what? Root of blob, which in this case is. Okay, let's look at this next one. First thing that comes to is blob squared, right? So that's a 2 blob with a 1. But I'm not done. I'm going to multiply by. Okay, how do I deal with this? Sine of x. Same thing. Root of sine of blob is cosine blob. And I'm not done because I got to take the derivative of sine. The last thing I come to is this thing. Again, it's blob squared, so that's 2 sine x. The 1 comes cosine x. I agree with that? Now, check this out. Out of this first 2 terms, I'm going to pull 1 over x. And out of these next 2 terms, I'm going to pull out a minus and a cosine x. Never match. As we should. Notice, by the way, you had to go through a whole bunch of chain rule crap to get this one. Whereas this one was almost immediate. It was a much shorter way to do it. Right? And by the way, this does come from the chain rule, but writing it in this form makes it a little bit more complex. So does that straighten it out a bit for you? That's right. That's right. So right. So here's. So I gave you this fancy formula right here. So let me make a couple of points here. I gave you this fancy thing here. F of x is the integral from R of x to S of x of f of t to t. Then this is my general fundamental theorem of calculus. This is f of s of x, s prime of x, minus f of R of x, R prime. So let's do a simple. And I'll see it. And this actually ties into the fundamental theorem of calculus. If f of x is the integral from a to x of f of t to t, using this formula, this is f of the top times the derivative of the top, which is 1. It is an a. Minus f of a times the derivative of a, which is 0. So just get x. Right, and that's simply, this is the statement. And if both x and a are both just numbers, then you get 0. And if they're both numbers, that just means that x is a number and it's derivative. Does that take care of Bryson? It's sure. Okay, so tell me what the interval is. We'll work it out. It's great. This is in contrast to this previous example because remember how I wrote it out explicitly, that long example. You don't know how to do this yet. You will be able to write this out explicitly later once you learn some great substitutions. But for right now, there's no good way to find an answer. So what does they ask? F of 0 and F of 0. It is. They shouldn't do. Yeah, you must have got some other part. That's correct. I can look at that and make sure there wasn't a mistake. That should be the interval from 0 to 0. Right, so there you go. Maybe you get that. Let's look at the F prime and see. I suspect that might be what it is. What is the derivative? Well, this is good practice with a little formula we've got here. First of all, you take your function and you plug in x squared. So that's 1 over what's that? T by x squared, right? And I'm not done. I got to do derivative plus up top minus plug in T 3x. That's the derivative what's on top. And so just because of so a little bit. Like that. That's everybody see how we go. Right. Just everywhere you see T, plug in top. That's it. And then multiply by the derivative. Everywhere subtract anything you see T, plug in bottom. Derivative bottom. Because the question asks, find f of 0, find f prime. So when I've got it this way, see, this is what the fundamental theorem of calculus. Whenever you have a function written in this interval form, this tells you how to take the derivative. Okay. So what else is on that problem? It might behoove us to finish that off. Okay. So let's do that. over x. Is that right? Okay, again, with the limits, what's the first thing to do? Plug the sucker in and see what happens. When I plug in x equals 0, so that denominator will be 0, right? When I plug in up here, I get f of 0, which is also 0. 0, 0, L'Hopital rule. So, try L'Hopital. Derivative of x, 1. Derivative of f of x, we already think. Now try to plug in 0 again. And this time you will be successful. That's a 1. On top, I get 0. I get -3 over 1. So I didn't make it. Not too bad, right? Hey, at this point, it's much better for it to be much easier and much harder to do stuff, right? But always remember that, by the way, when you're taking the test. I mean, I would not say anybody would ever accuse me of taking problems that are too easy, but I'm telling you, you all have the ability to make it much harder than I do. But don't do that. Always look for the easy way out. Wasn't there also one about infinity f of x over x squared or something like that? Oh, and I did say on that quiz, didn't I, that you could assume that this goes to infinity, x goes to infinity, or maybe I said that. It might not be on there, but I think it said that. Anyway, and by the way, yeah, there is. You might think, just for fun, to try to verify my claim, and I'll put it to you this way. This thing looks very much like 1 over t with values. So this depends on the fact that the log goes. You might think, well, that's true. I didn't expect you to show this here. So if you believe that, and that's going to infinity, that's going to infinity. So what we call it again, I can something and try. This is 2x. The derivative at the bottom, and again, the derivative at the top is 2x over square root x4 1 minus 3 square root 9x squared plus 1. And now I'm going to write this. This is a and b over the denominator. I'm going to write a over the denominator. This divided by 2x is just 1. And this over 2x, this. Now as x goes to infinity, denominator here getting huge. Here, denominator also getting huge, 0 minus 0. So that one was. Okay. Other questions? All 2015. Yeah, maybe I can. This is number 7. Use a limit. Oh, yeah. So if I would ask you a question like this, so it says, let me just write it out. says use the limit. Fine. Area under light is 3x squared plus 2x. Okay, good. All right, so this is what's level. Yes. At 1, this is 5. At 3, this is big, like it's 27.6. And you know, it does. But anyway, certainly this thing's never negative, right? So it does make sense for you to say area, but that doesn't matter. So how do we do this? Well, the big thing when I say use a limit, is that what kind of confounded you a little bit?
No, I worked it, but not as you can.
Check. How can you check? In fact, I'm gonna put the cart in front of the horse this time. Right? I'm gonna do this probably the way I said. I'm gonna do it the way I told you not to do it this way. Check. How can I check this? Well, okay. Maybe I won't do that first because let me ask you this. I want to make sure everybody's on the same page first. What do I mean by use a limit here? Use a limit. What does it mean? Yeah, that's right. That's your. So we put the boxes under there, right? That's essentially what we're talking about here. And so what do we have? We have the interval 1 to 3. And we have this crazy formula that the f of x dx is limit y'all all remember that? So do me a favor, and you can always rederive it if you forget it. I will charge you points if you forget it. Just remember this. But basically what this comes from is this means we divide the interval up into n equally spaced pieces. And we're always using, by the way, what are we always using to determine height? This is determining height as I'm putting in a function. You remember what we're using? We're right in on there, so that's what this one is doing. This is the width of every little box, and this is the function with writing, right? For this problem here that I'm asking about, what are my players? What's A? B? And f of x. So let's see what this translates to. The limit is n goes to infinity. B minus A is 2 over n. F of, like better than 0, but here's what it is. Everybody follow that? Right. Now, I need to do the function thing. let's see, what do? I gotta plug this awful thing to this function, so it's gonna be 1 plus k 2 over n squared plus 2 everybody agree with that? Okay, this is where you told me that. This is 2 over n. This is 3 times 1 plus a 4 over n. Then and then k squared 4 over n squared plus 2 plus 2k over n. Yeah, I know it's nice. What did I do here? I just multiplied this to 2. That's a 2k over n. But what did I do here? I just squared this message. So it should be 1, 2 times product of 2, so it's 2k over n. And then the square of the left, just k squared. You let you guys catch your friend. Well, hello, is this looking familiar? Were you on this path?
Yeah, so where I messed up was with the one plus. I think everything else right except for like I was so used to having zero there. That on accident.
Right.
So,
Yeah, because I saw you laughing earlier. Like,
Yeah,
let's
that's
see.
what it was.
So let's keep going. This is 3 plus, let's go, 6, 12k, 1 over 10. Well, actually, let's do this. That's my 3 times 2 is 6, 12, k times 12 over n. That's going to be k squared times 12 over n squared plus 2 plus k 4 over n. Right. Okay, so we group it together a little bit. Let's see, 3, 2 is 5. Let's see, the k stuff, I've got 12 over n and 4 over n. And I've got 12 over n squared. Now, what I'm going to do now, by the way, a good kind of, I keep writing this limit down every time, it's all proper, but notice, I'm not even going to do anything. You shouldn't be doing anything with limit. Just along for the ride, be correct. This is limit, z goes to infinity. 2 over n times 5 16 k plus 12. Seven sums here. This is 10 again. Sum. Children, 32 over 10 squared. A. She's 24 over 10 cubed. I want to make sure you'll catch up and I know what I did. Steps. Okay, so I basically broke, I multiplied this 2 over n. So that's 10 over n times 1. Right? 2 over n times 16 over n is 32 over n squared, just a. And 2 over n times 12 over n squared is 24 over n cubed. So by the way, what do I do now? Yeah, that's right. So these are available on plan. I bet you guys can tell me this. What is 1 plus 1 plus 1 plus 1 plus 1 added up to something? Not 10 times. 10. Okay, it's 1 to n. 1, 1, 1, 1 added to itself. Anybody remember what this one is? That is 1 plus 2 plus 3 plus 4. 4. Right? Right. And how about this? That one's hard to remember, right? It's n plus 1, 2n plus 1, 5 plus one there. There you go.
I was just forget the N. I remember the N plus one, I remember the 2 N plus one, forget the leading.
Right. Well, remember, notice kind of a, for just k, it's 2 powers of n. It's just a constant, it's 1 power of n. K is 2 powers of n. K squared is 3 powers of n. Okay, so let's see this. Then n goes to infinity. Okay, so let me simplify this stuff here. This is 10 over n times n, which is 10. And then I get 32 over n squared times n plus 1 over 2. And then I get 24 over n cubed n plus 1, 2n plus 1 over 6. Oh, this is a great time to practice those limits I was talking about earlier, back from 1040. So let's do it. As n goes to infinity, where does 10 go? That's just 10, right? Now watch this. I can cancel some stuff beforehand. What's the biggest power of n you see on 5? The square power. Everybody agree with that? What's the biggest power of n that will be on top? N squared also. Got a tie. The limit, since we're going to infinity, should be the ratio of the leading coefficient. What's the coefficient of n squared in the bottom? Read the whole thing. 2. When you multiply that out, what's the coefficient of n squared up here? 32. Everybody agree with that? Square term, it's a tie, so that's the limit. How about this one? What's the biggest power of n you see in the bottom? 3. Biggest power you see in the top? Power. Yeah, in the top, the power you get, biggest power is also 3. Got a tie. What's the multiplier of the cubic term, the 3 term in the bottom? What's the multiplier of the cubic term in the top? Careful. 48, that's right. Because it's 2 in cube times 24. So this should be 10 plus 16 plus 8. It's 30. Everybody see how we, if you're not comfortable with that, you can cancel some stuff out, you can simplify it, you will alter what you like, but that's a quick way to see. Everybody understand what we did? Okay, let me get back to my original question. Okay, so we've gone through what was written all. I mean, I even had to erase the boards. How do I check it? I have a lot of sympathy for people who check their answers, double check themselves. That's an important skill to have. Would everybody agree that the problem that we just solved was this? Ask for an area under a curve. That's what we just did. Right? With all the limit stuff, this is what we just did. We found that number. Use the fundamental theorem of calculus. What's your favorite antiderivative of that 3x squared? What's your favorite antiderivative of 2x? So that's going to be 27 plus 9 minus 1 minus 1 is 34. It's a lot quicker, isn't it? If I ask you the limit, I expect you to see that. That'll be a big part of it. Now, if you at least show me you know what you're doing, then I'm not going to give you 0 for it. Right? And I especially like it if you get some kind of wacky answer. Like, so let me give you an example. Suppose you did your thing with this limit, and it's easy to slip up there, and you get -3. Tell me why you know that cannot possibly be the answer. This function between 1 and 3 is always positive. Do I agree? So I don't know much. It's giving me an area. It's giving me a positive area. When I get -2 with this answer, I know that's wrong. Tell me that. All right. One of the things, I know this may sound kind of, one of the things that you can do in mathematics and really books, I was develop a few things, develop an intuition, do your answer. This will serve you well. All right. So like I said, you tell me that you think you've got something wrong. If you're sure you're wrong, don't tell me all your problems. think is wrong, right? You've got everything right. Give me a mathematical reason or some kind of reason why you think it's wrong. Please don't write, oh, I've got a 40 average on the test, so I'm sure I'm wrong here. That's probably not a good answer, but if you tell me, I got a negative answer. And that's something perfect. Oh, I'm computing a volume, right, and I got a negative answer. I had a calculus student many years ago, and she was really good. Not arrogant, but confident. She knew what she was doing, etc. And I had this related race problem. And it's actually kind of an interesting problem because the problem was, I'm going to get some numbers wrong perhaps, but you're camping in the mountains, you're up in the mountains. Sun rises over this mountain, and at 10 o'clock, the shadow moves past you at 2 feet per second. How tall is the mountain? And it seems like there's not enough information there. There is enough information to figure out how tall the mountain is. And so she did, all her calculus was good. I thought probably she messed up somewhere. I remember her writing at the end of it, yeah, I think I did all the math right, but there's a silly area in there somewhere because my mountain's 3 inches tall. I was like, yes. Okay, other questions? Um, Children, you have it? Correct me if I can just. It's 59. Did I get that right? Okay, so let's do it. First of all, I've written very badly. This is definitely something I want to write. I want to do fundamental theorem of calculus. This is much easier for me to deal with. But so this is just an exercise on the inside of it. I want to use fundamental theorem of calculus. So here we go. What's your favorite antiderivative of x to the minus 1? Oh, good, good, good. I'm going to do it. I'm going to do it once. I'm going to step ahead on it. That's good. It's that if you're in the jam, right? Right? Evaluating from 164. So I am looking this up. That's 1/2 plus 3x. And again, you can test yourself by taking the derivative, this, and if you get back here, then you're good to go. So this is Put in 64 here, and that's 2 times 8. This is 3 times 64 to the 2/3. The cube root of 64, 4 squared is 16. Minus, when I put in 1 here, I get 2 plus 3. So that's 16, 48 is 64 minus 5 is 50. Oh, by the way, is that yes, I put in 64 first. 264 is 8. And then 3 times 64 to the 2/3 power. That's the cube root of 64 squared. So 4 squared. Now I got to plug in 1 and subtract off. I put in 1 here and 2.
So that one you don't.
No. This is just a straight up fundamental theorem. Nobody's actually taking a derivative. You just need that number. Please resist the temptation to write the antiderivative, this, the antiderivative. You can't do that. That's as big a sin as doing the product rule, x sine x, taking the derivative of the same time. How would I do this? This is a select. Multiply the thing out, power to x. Take a couple steps. So first I'll do this, x is 1/2, and this other piece is x squared minus 1. So this is, see, that's 4 halves, so it's x to 5 halves minus x to 1/2. So this is, my favorite antiderivative, this is x 7 halves over 7 halves minus x 3 halves over 3 halves. Which is 2/7 x 7 halves times 2/3 x 3 halves. When I put in 4 here, the square root, so I get 2/7. The square root of 4 is 2, 7 power is 28. Square root of 4 is 2, cubed is 8. Minus, when I put in 1 here, I get 2/7. Put it in here, it's 2/3. So this is going to be 256 sevens minus 2/7 is 254 over 7. And that is 2/3. Right. This is going to be minus 16/3. And actually, if you're not going to test, stop there. Unless there's something. Don't waste valuable test time, risk getting it wrong, looking around. Okay. Remind me real quick what that is.
What variance be greater than average value of x? You there,
Well, the average value is 0 on the other. So what value is the well, F average is equal to 1 over B minus A. But you just take the integral and divide by the. Now, in this case, B is B, and what is A? A is 0 in this specific case here. That is correct. So adapted to our case, 1 over B, integral from 0 to B, and my function is x cubed minus 3x. So the upshot is this. I want what over B integral from 0 to B x cubed minus 3x next to be 0. Now this means 1 over B is not 0, so this thing. So this gives me an equation, right? So just do this, but fundamental theorem. What's your favorite antiderivative of x cubed? X squared 4, 5. And how about this? Sort of right next. No. So this thing needs to be 0. So this should give me an equation solve. When I put in B, I get 1/4 4 minus 3/2 B squared minus 0. Right, because clearly when I put a 0 here, it's 0. And I want this equal to 0. So I get 1/4 B squared minus 3/2 B. So 4 squared is 0. So I'm just going to solve this for B. The easiest thing I can do is pull this out. Do I agree with it? So one solution is what we did, I get from this. Or I could have B squared 0, and this is not allowed. Because it's bigger. So I agree about that. 1/4 B squared equals 3/2. So in other words, it's other term. This square equals 6. Correct. And this means that B equals minus radical 6, radical 6. And again, that. So the answer for that is 6. And actually, so I have in this course, I have beaten this function today. I'm sure. It's actually kind of a good function to illustrate a number of concepts. What's happening in this problem? Notice I got 3 answers out of this. I actually got 0, minus radical 66. This function called is something like this. I will average, so this is radical 3, 0 right here. This is minus radical 0. Get the average value to 0, we had to get the interval to 0. Notice that going from 0 to radical 3, you're going to get a negative, right? Because everything's in the curve, right? You actually have to go out to radical 6, wherever that is, get in a positive area to cancel that out. What do the other solutions come from? Well, if you got, this is going the other way, right? You're integrating backwards here. And the other solution is 0, that means you didn't integrate anywhere, right? So that's, it sort of makes sense that I get these 3 particular solutions. Yes, because one of our, actually the average value, for the average value to be 0, that means the input. Right? Because remember, B is not 0. So this times this times that interval of 0, that means one of these 2 is 0. But 1 over B can't be 0, because I said that B had to be positive. Okay. This one. There. Boy, that was, it wasn't. How do I know to do that? I don't care. I don't care how many times you pull 1080. There's no good clean way to integrate this. Right? So remember, you've got several things at your disposal that I asked you to do. Number 1, can you find an anti-derivative good one? Right. This is definitely hot. Right. Another thing you can do is do shapes with the circles, lines, and so forth. This I have no idea. So really, the only thing you've got going for is symmetry. Notice, and here's something else to notice. What do you notice about this interval? It's symmetric about 0, right? It's got 0 dead center. I bet this is an odd function because it's still haven't been answered. if you have f of x equals e to the x squared tangent 3x over the square root of x4 plus x squared plus 1, then f minus x yeah, I can't imagine answer to that because yeah, and this interval is too big. 5 power series. Actually, I should have said 77. What is the problem here? It says 77, didn't I? Didn't say, something smaller. Let me show you. F of minus x is e. So I'm replacing every x with negative x. I know what I did. Over square root of minus x 4 minus x squared. Right? Now, notice a lot of this. Minus x to the fourth power is x to the fourth power. Minus x squared is x squared. This is the x squared. But this is times minus 35. If I remember from the old days, it's an odd function. So this is minus e to the x squared and 3x over x4 plus x squared 1. So this is actually an odd function. But I typoed this. I meant this to be inverse tangent 3x, which is also. What's the problem with integrating this? Right, so why did I get distressed when I saw that I actually see if I remember where does the tangent have a problem? Well, you're close. And tangent's got a problem with power 2. It's got every place that the cosine is 0, it's got a 0 in the column. And pi over 2 is about what? 1.5, right? And so 3x, that goes up to 21. So this will actually run over several places where it's not. Right. So this interval technically doesn't exist by what we had. You might be able to repair this with stuff in 1080, not this. So that was actually wrong. But if you have an odd function on the symmetric interval, if the interval exists, then this would be 0. So let's use because the inverse tangent is defined everywhere. It's continuous. There's no problem with the exponential, and I remember taking great pains to make sure that this denominator is not 0. It's not here. Yeah, like I said, I meant to write inverse tangent because the inverse tangent function find it's got problems every power 2. Well, I should say it's got a period of pi and it has these vertical asymptotes all right. Tangent of 3x is worse because it magnifies the problem and this will go around 7. So this will run through several vertical asymptotes. But inverse tangent looks like this. And this is how big. Yes.
I think circle the first thing you do is figure out the part of where the 7 are, and then I how do you do this for the process?
Let me do another. So there's all kinds of ways I could do circle problem, of course. Well, let's see. Oh, yes.
So we actually had gone over to honor and gave us that on the quiz. So how would you want to do that with that quiz? We didn't go over audit even.
I did that.
That was 2 days ago. So
Yeah.
how would you want us to?
I did talk about that. Yeah, I did a couple of problems actually in that lecture. Where I might have slipped on the radar. The class is lasting.
I was like, I didn't see it in my notes for today.
No, yeah, I talked about it right before the quiz, and actually did an example that day, but I see how it can easily slip in. Yeah. Well, I mean, that would be something that, I mean, what geometric shapes do you do really? Right? I mean, so if I asked you to do. Say 0 to 3. Well, actually, this is one that you can do before. You can actually do the limit. You know, it's a lot of trouble. You can fundamental theorem of calculus. It's like an x squared minus x. If it's something like 6. 9 minus 6, and you can plug it here. But you can do this geometrically. Now that we could grab this from the knee. So, by the way, what is this? What's the general form of this? Yeah, it's a line. And 0 minus 1. And it ends up at 35. This 1, 3. So how can I do this? So what you have this little triangle right here. It contributes negative. Right? This is the point. Where does this cross the axis? Why is? So y equals 0, x is 1/2. So this is the point 1/2 0 right here. And this is the point 35. So this triangular area here is half the base, 4 times the height, 1. So this is minus 1/4. The area of the triangle is 1/4, it's hanging in the x-axis. Here's that. Right? And this piece of the triangle is all the way above the axis. And this one might be a little easier. The height of this triangle is 5. The width of this triangle looks like it's 2.5. So 5/2. Agree? So the area of this triangle is half the base times the height, so it's 25 feet. I agree. So this should be the positive contribution added to the negative contribution, which is 24. But you know what? If you're forced to do something geometrical now, really the only thing that you've got going is it linear, right? Or is it a circle, right? Because those are really the only two things. Or is there a piece of it that's odd? That's also, if it's not a line, and you can't do it, then I'd check to see if it's a circle. Right? That would be my best. Yes. If I don't tell you how to solve it, which I usually don't, I don't care what you do. Anything's free. Right? I usually like to do it that way. You know, like when y'all were in 1020, did you ever get instructions on your exam about find this limit and don't even what we call rule? Right. And so I never do that. I mean, because I realize some kids come in and they've already seen it, and it's like, here's the deal. Here's my deal. If you use something I haven't done yet, that's fine. But if you don't do it right, I'm going to stick it to you. Right? Kind of. Yes. So what you're trying to find the limit of. Are you talking about doing the integrals by the limit? Okay. What is the actual title of this? That is probably the definition of the definite interval. That's probably where you're going to find the definition of that. That's right. The little formula I gave you is a special piece of Riemann sums that you want to do. In general, Riemann sum can be any subdivision, et cetera, et cetera. And I give you that kind of systematic way if you need to do it. Okay. Other questions?
I don't know, down, right, it's just at the end, I got it. I got this one thing.
Can you remind me what that problem is?
It's the integral of 5 to negative for the absolute value. Value.
Oh, right. I'll do this 2 ways. Let me just draw a rough sketch of what this is. -1, -2, -5. So this triangle, so that what you're doing, this looks like a V, and it's a little bit steeper than standard V. So this is this is -2. So let's see what we got. 5, 4. Half the base times the height, that part. And this is 10 times 5 wide. This triangle is there. Okay. So this should be 2 plus 20, sorry, 4 plus 25. 25. Well, I'll do this another one. You can also do this. Let me remind you, so if you want to do, this is longer. I mean, the way I did it, that's what to do this. People problem, but. Absolute value of 2x is, leave it alone if it's positive. Change the sign if it's negative. So if I do this. The problem with this stupid thing is I don't know an antiderivative of this, but I can use properties of the integrals to break this up. It's kind of fun to watch this work too. That's that property of integrals. Going from -2 to 5 is going -2 to 0 and 0 to 5 with the whole shebang. And the reason I broke it up this way is because I know a better formula for this. In the interval from -2 to 0, the absolute value of 2x is negative 2x. Okay. And in the interval from 0 to 5, the absolute value of 2x is just 2x. So I've got two intervals to work out. So this one is -x squared, evaluated -2 to 0. Antiderivative -2x is nothing greater. And this one is x squared, evaluated from 0 to 5. And this comes out to be 0 minus -4. And this other piece comes out to be 25 minus 0. So I get 4 plus 25. And notice how the pieces came out exactly. Makes sense? Okay, other questions? Think so? What do you mean? Anything that we've talked about in the past 4 days or whatever that I don't know? Yeah. Yes. Okay, what's it? Yes. Okay, so what we're going to do is we're going to integrate this thing. Integral of 0 to square root of 40, that's what it was. Okay, so what does part A ask us? This is our goal. Okay, then. So if we divide this, and I think it said we partition this into n equals 7, right? Okay, so we have radical 3, 0. We break this up into n evenly spaced out, right? Length of each subbing. Actually, what you're doing here is almost writing the formula that I gave you. The b minus a, and blah, blah, blah. What is the length of each subbing here? If it's radical 3 long, and I divide up into n pieces. Well, it's the total length, which is in this case square root of 3, divided into n pieces. Even. You okay? Wait, we need a formula to write in point. Let's see if I can close. First, the first right-in point is right here. Agree? Because that's the right-in point of the first interval. It is not 0. 0 kicked over by 1 width. Radical 3. Agree with that? So this is 0. You kick it over by 1 width of one of these things. So radical 3 over it. What's the second? This is right in point of the second interval. Two lengths over. Third, 3 lengths over. How about the K? There you go. There's your point. What's part B as? How do we get the height of the cave problem? What are we actually doing? Here's the cave box right here. We're taking its endpoint and sticking it into the function. Agree? So what do we actually do? Well, we take the right endpoint, take box, which I've already figured out. It's this. And we shove it into the function. We put it in the function that fills in. Where is it? And my function in this case, of course. So there's the formula for the height. Now, it also asks about the area. Right? So I've got the height of the cave box. Well, I need to multiply the height of the box by to get its area. Width? What is its width? They are all that wide. Right here. So this would be so there's your area. Actually, I'm going to bother to clean this up. Let me clean this area up. If I cube this, I get K cubed 3 radical 3 over n cubed is minus 3 radical 3 k n radical 3. So I'm gonna multiply that in because it actually allows me to do some radical 3s. This is actually 9 k cubed over n cubed minus 9 k squared. I've got to multiply this in here. So this is a pretty concise. This is the area of 8 plots. Now, what is part C? So the Riemann sum we get, so that, what I've got over here, that's just the kth box. So we need to add them up. Whatever. Minus 9k squared. But I will clean this up. This is 9 over n4 sum k cubed minus 9 over n squared sum k. Agree with that? Now, this is n squared, n plus 1 squared, over 4, right? And this is n plus 1 over 2. So my area now be rewritten as 4 multiplied by 9 fourths, 9 n squared, n plus 1 squared, 4 and 4, minus 9 n plus 1 over 2. There's a nice good formula for area approximation. By the way, what happens as n goes through? This is again, we'll do that same exercise that we did last time. Let's look at this first. What's the biggest power we can see on the bottom? 4. Biggest power on top. Also 4. Ding, 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 that's a tie. What's the coefficient of the 4 term on the 4 power term on the bottom? 4. What's the coefficient of the 4 power term on the top? 9. Because when you square this out, you have an n squared, it's where it says 9. Okay. Biggest power on the bottom, 2. Power on top, also 2. A tie. 9 halves. 9 is coefficient n squared on top, 2 is coefficient n squared on bottom. So I get minus 9. Again, you can check Because now we have the fundamental theorem of calculus at our disposal. Let's do this really quick. Notice we have a negative answer, so this thing must be hanging under, and it is. It's axis here. This is 1/4. X4 minus 3/2 x squared evaluated. Radical 3 to 0. So radical 3 to the 4th power is 3 squared. That's 9/4. Radical 3 squared is 3 minus 9/2. Or I put in 0, I get 0. So I get minus 9. Questions on this? Well, we're almost there, folks. That's 10:04. We are going to have a couple of days. On schedule, we've got a couple of days. We'll obviously take quizzes those days, but we're gonna go back. I want you to think about what's bothering you about the course. Anything you're coming up on, we'll go over that pretty well after we cover the new material, which will only take 30 and Friday. Run a couple of days next week and kind of get everything polished up. And work hard on making sure that you show up those. I don't think anybody accuses me of my test of being easy, but final exam is something a little bit more routine. I want to make sure that you will have the skills to go on in a like fundamental skills. So make sure that you're good in your fundamental. Okay, come on, Steve. Thank you.